So the first one, I don't know what to do from here. This is a race car travels 40 meters a second around a banked 45-degree circular track with a radius of 200 meters. What is the magnitude of the resultant force on the 80-kilogram driver of this car?
Alright, so you kind of got the idea, you got your track drawn. I'm going to draw it a little simpler like this. Did you say this is 45 degrees? You've got a car, and then there's a driver in the car, right? So the driver in the car, will he feel the same kinds of forces as the car will?
No.
No, you're right. So let's see. Just draw him in there. Will he have the same acceleration as the car will, though?
Yes.
Yeah. So let's see here. What does it tell you? His car travels 40 meters per second. Okay. So he's going 40 meters per second. The mass of the driver is 80 kilograms.
Yeah.
Is he going to have an acceleration?
No.
So what kind of motion is this? He's going around in a circle. Let's see, 200 meters.
What kind of motion?
Mm-hmm. There's kind of a term for it.
I don't know.
So he's in uniform circular motion.
Okay.
So you remember before we were talking about circles like this? And there's two kinds of acceleration. Remember doing that? Tangential acceleration and centripetal acceleration.
Yeah. So he'll have centripetal,
Yeah.
but
So-
not tangential.
He'll have some centripetal acceleration, A sub R or A sub C, but no tangential. All right. Can we find the value of his centripetal acceleration?
Yes.
What's the equation for that?
I don't know.
So there's two of them. It can be V squared over R or omega squared R. Remember those?
Omega? No.
Omega is the
Is that
angular
W?
velocity. It's a fancy looking W. It's a Greek letter.
Okay.
So that's going back to chapter 4. Omega is how quickly the angle is changing. So like if you go this angle in 1 second, that would be your omega. But for this problem, we don't need omega because we're given a velocity, right? So what we did do 40 squared over the radius. So this gives us our acceleration. Oh, so it's 1600, right? 40 squared, 4 times 4, 1600, yeah. Does that make sense? So we know he has an acceleration towards the center of the circle of 8 meters per second squared.
Okay.
So what does acceleration have to do with force, though?
Well, force is acceleration times mass.
Okay? This is the net force. So that's his only acceleration. So we know acceleration is 8.
We know his mass is 80 kilograms. So that should give us the force.
So what's this?
Uh, 640.
And what was the question asking for?
What is the magnitude of the resultant force on the 80 kilogram driver? So where do we use the 45 degrees?
We don't. It's superfluous. We don't need it.
Okay. How come we didn't really need to do our force diagram for this problem?
Nope. Because we could solve for acceleration directly. And then we can multiply that times mass to get the resultant force.
Alright,
So if it says find the resultant force, all I have to do is find the net force, which is equal to mass times acceleration. Okay. There's that one.